Okay, let me continue again on sheet pile wall, and just in my previous lecture I have discussed about analysis of retaining wall, particularly for finding out the depth of embedment, and I have shown different combination of soil condition, that means above dredge level, below dredge level, what is the soil, sand cohesive and cohesive, but we have discussed only sand combination. And again as I have mentioned that in the sheet pile wall always there will be water table most of the time, but we have considered without water table, and that is one thing. And again that analysis can two types, like one is rigorous analysis, another is simplified analysis. And now I will take a problem by and try to solve by rigorous analysis and also by simplified method. So, that is the application I will try to show immediately, and then we will see the result. So, this is the problem actually. Problem is like this: determine the depth of embedment for the sheet pile wall shown with h equal to 6 meter, phi equal to 30 degrees, gamma equal to 17 kilonewton meter cube by the rigorous analysis and by simplified method. The two method actually you have to use, and that so this is the wall actually, this dredge level. So, here actually h equal to 6 meter. So, h equal to 6 meter and your gamma here. So, that equal to 17 kilonewton per meter cube, and your phi here, both are cohesive soil, cohesionless soil, phi equal to 30 degrees. So, this is given, and if this is the one, this is the analysis also I have done. So, this will be the corresponding pressure diagram. So, my unknown is y naught, my unknown is d naught, and finally, d. Okay. So, this step by step if I follow, then I can do it. So, for this you can refer this figure, and then I will all steps in calculation I will try to show, and you can see here first of all actually you can find out K and Kp. What is Ka equal to 1 minus sin phi by 1 plus sin phi, and that will be equal to 1, if I put phi equal to 30 degrees, then it become 1 by 3, and Kp become 1 by Ka. So, it will be 3, and K will be equal to Kp minus Ka. So, that become 3 minus 1 by 3. So, it become 2.67. Okay. And Pa bar, you can say first quantity Pa bar will be gamma h Ka. So, gamma is actually how much? Gamma is here 17, h equal to 6 and K equal to 1 by 3. So, that become your 34 kilonewton per meter square. Then your y naught, next step is y naught become Pa bar gamma k. So, that means it will become 34 divided by 17 multiplied by 2.67. So, that become 0.75 meter. And now, you can find out Pa, that is your Pa. That is actually, if I go back to that diagram, you can see Pa is this one, the area of this diagram. Okay. So, Pa will be, you can say half Pa bar into H plus half Pa bar into y naught. So, if I do that, half multiplied by Pa bar is how much? 34 multiplied by 6 plus half multiplied by 34 multiplied by y naught is 0.75. So, this gives you 114.75, 114.75. Okay. And now, P p under bar, this will be equal to gamma d K p minus K a minus P a bar. So, this will be equal to 17 multiplied by d and this is 2.67 minus P a is 34. So, that means it will be 45.4 d, 45.4 d minus 34, and P p bar dash, that will be equal to gamma h K a plus gamma d K p minus K a. So, that gives you 17 multiplied by 6 multiplied by 1 by 3 plus gamma okay. So, this will be 17 d multiplied by 2.67. So, this ultimately become 306 plus 45.4 d. So, these are the things we are getting. So, I will go to the next page. So, next page will be P p bar double dash, that will be equal to gamma h K p gamma h K p plus gamma y naught K p minus K a. So, if I put, then it will be 17 multiplied by 6 multiplied by 3 plus 17 multiplied by 0.75 and multiplied by 2.67. So, this gives you 340 kilonewton per meter square. And then to find out y bar, I can do P a y bar equal to half P a into h, half P a into h into h by 3 plus y naught. If you look at diagram, then we will find out. So, that on diagram is there something like this. So, this is the one. So, you have to find out y bar from here actually. Y bar, suppose this is acting here. So, y bar is this one. So, y bar, so this area multiplied by the distance from here to here actually. So, corresponding to this area C g is somewhere here suppose, then this will be h by 3 plus y naught. This is y naught, this is y naught and this is h by 3 suppose. So, that is what is done, Oh sorry, this is different, and plus half P A bar y naught. So, this area actually, this area you have to find out this area, and this C g from here actually 2/3 y naught, and if I put all values, then ultimately y bar will become, I know this, I know this, I know this, everything is known, and I know this also. So, y bar ultimately will become 286.9 divided by 114.75. So, that gives you 2.50. Okay. So, and your final equation will be d naught to the power 4 plus C 1 d naught cube plus C 2 d naught square plus C 3 d naught cube plus C 4 equal to 0. Now, one by one I have to find out C 1 equal to actually P P bar double dot divided by gamma k. So, it will be equal to 34 by 17 multiplied by 2.67, that gives you 7.4, and C 2 equal to minus 8 P A divided by gamma k. So, that gives you 8 multiplied by 114.75 divided by 17 multiplied by 2.67. So, that is actually minus 20.2, minus 20.2. Then your C 3 comes minus 6 P A divided by gamma k whole square multiplied by 2 y bar gamma k plus P P bar double dot this one. So, this way if I calculate, so it will become minus 6 multiplied by 114.75 divided by 17 multiplied by 2.67 whole square, 2 multiplied by y bar is how much you have got 2.5 multiplied by gamma 17 multiplied by k 2.67 plus P P bar double dot actually how much 34. Now, P P bar double dot is 340, P P bar 340, this is 340. Okay. So, this one if you calculate, then it comes actually, this comes minus 189.5. So, this is become C 3. Now, I will get C 4. C 4 will be equal to C 4 will be minus 6 P A y bar P P double dot plus 4 P A square divided by gamma k whole square. So, if I put this, it will become minus 6 multiplied by P A is 114.75 multiplied by 2.5 multiplied by 340 plus 4 multiplied by 114.75 square divided by 17 multiplied by 2.67 whole square, and then you will get minus 309.6. Okay. So, we are getting this. So, all coefficient I have got. Now, if I express, then I am getting d naught to the power 4 minus plus 7.4 d naught cube minus 20.2 d naught square minus 189.5 this is, I will put this 189.5 d naught minus 309.6 equal to 0. So, this is the equation, that means d naught to the power 4, this is the equation, minus 189.5 d naught multiplied by d naught minus 30. So, this is the equation, and so I have to solve for d naught. Okay. I have to solve for d naught. So, if I want to solve for d naught, then what I will do, I will assume a particular value of d and find out the value of this function. So, as I have told you that as a guideline, what I can do, the d naught can be taken as same as your depth of embedment. So, if I take d naught equal to 6, this function gives you a value 720, and if I take if I take d naught equal to 5, this gives you a value equal to minus 212. If I take 5.5, this gives you 183 something, and if I take 5.4, this gives you 158, and if I take 5.3, this gives you 9.3, and it is quite close to 0, I can say. So, I can assume that solution for this equation is d naught equal to 5.3. So, your d become 5.3 plus y naught actually is 0.75. So, that become 6.05. So, actual d required will be equal to d multiplied by, suppose 40% increase, if I do the 1.4, if I multiply, then it become 8.47, and which is nothing but 8.5 meter. So, that means the if I go back to the problem, so for this problem, when the depth is 6 meter and your soil phi is 30 degrees, gamma is 17, then your depth of embedment required, for safe design returning. So, it is 8.5 meter. Okay. So, these are the if I go back from here, so this is the step 1, then this is the page 2, that means different coefficient I have calculated, then this is page 3, that equation I have got, and then finally solving this we have got equation 7.5. So, all those things now, so that is this is the solution I have obtained by rigorous analysis. Okay. Let me see now so, let me see now by simplified method. If I do by simplified method, this is the diagram, and I have shown the corresponding equation that I have to assume that this is the wall. Now, wall height assumed to be h plus d, and for that I calculate active pressure, and wall height actually is d, and for that I will calculate passive pressure. And for equilibrium, this pressure and this pressure must be equal, and if I do that, then as I have shown that I have got an equation, which equation was simplified equation was actually your k dq minus 3 k a h d into h plus d minus k a h q equal to 0. This was the equation. So, this is the equation, and everything is known. H is 6, k equal to 1 by 3, k is 2.67, and if I put all those things, suppose if I put all those things, then I will get an equation 2.67 dq minus 3 multiplied by 1 by 3 multiplied by 6 multiplied by d multiplied by 6 plus d minus 1 by 3 into 6 cube equal to 0. And if you simplify this, then I will get a equation equal to dq minus 2.25 d square minus 13.5 d minus 27 equal to 0. So, I will get a rigorous analysis. Based on rigorous analysis, I will get this equation, and if I get this equation, you can see this is a cubic equation. So, I can assume a d value equal to 6, then the function value comes actually 27, and then by reducing the d value at value d equal to 6, value d equal to not 6, actually 5.6, this function gives you a value equal to 2.47. So, that means I can assume that solution of this equation d equal to 5.6 meter, and since it is a simplified method. So, d required as I have done 5.6 multiplied by 1.4, if I do, then this become actually 5.6 so it will be so 2.24 will be added. So, 5.6 plus 2.24, so that become 7.84. It is coming around 7.84, whereas we have got previous analysis around 8.5. Okay. So, this is the only difference. Actually, we are getting little lesser depth here by simplified analysis. So, it may not be. So, you may have to use more factor of safety, bigger factor of safety. So, otherwise for approximate analysis, actually to get an idea. So, if you have enough time and scope, and so then in that case you can do rigorous analysis, but by simplified analysis what will be the depth required, we can get a just initial estimate. Okay. So, so you can see that if you want to do rigorous analysis, you have to refer the all those things, calculation you have to see, and based on that you have to arrive at the solution. But if you do the simplified analysis, there is nothing. One side you consider wall height equal to h plus d and then find out active pressure, and other side you consider wall height equal to d and find out passive pressure, equate, get the equation, solve the equation, then you will get the analysis answer. And so, that may not be correct, accurate. So, you have to get the correct value. What you have to do? You have to do the aggregate analysis. So, to get a preliminary estimate, one can do this, and otherwise it is rigorous analysis is preferred. And finally, as I have mentioned that in the examination such a lengthy problem is difficult to do, and particularly for you this simplified method will be important for your. So, you can practice this one, and other whatever things are available, actually when you need to do design in the practice, you can refer book and do the follow the steps and get the solution. There is not a problem, but for exam purpose perhaps we will try to avoid this complicated rigorous analysis. Okay. So, with this I will stop here. Thank you. And next class, next lecture, I will try to take the anchored sheet pile wall, how to analyze and how to find out finally depth of embedment. And actually, in the anchored sheet pile wall, there are two things. Here, actually, one important thing, that is depth of embedment and the thickness. Thickness will come from bending moment and all, which I have not shown, but I may discuss later on. And anchored sheet pile wall, actually two things will come, not only depth of embedment one part, and in addition to the depth of embedment, you have to find out anchor force, because the anchor has to be designed. Anchor, if I have to prevent too much of settlement, I am putting anchor. If the anchor cannot support that much load, it may tear or it may slide, so many things can happen. So, to design a proper anchoring system, you need to find out the anchor force. So, those two things I will do in the next class. Okay. Thank you.